All right, so this is meant to be an introductory little video on how to find current in a circuit. Okay, so we're gonna start with a little simple series circuit to find the current in each of these little resistors. So this is a series circuit. We have a battery right here, 30 volts. We have an indication that the current coming out of the battery is 3 amps. It goes around and around and around and back to the beginning. So one thing to know, what we have to figure out is what is going to be the current here at this 5 ohm resistor, bloop, what is going to be the current at the 3 ohm resistor, and what is going to be the current at the 2 ohm resistor. Now, the thing to keep in mind is in a series circuit, current anywhere is going to be the current everywhere. Okay, so I'll write that down. Current anywhere is the current everywhere. In a series circuit, only in a series. So that means if we got 3 amps going around this corner, guess how much is right here? Well, this is just going to be 3 amps. Okay, guess how many amps is going to be right here? Also 3 amps. And guess how many amps is going to be going through this resistor right here? 3 amps. Don't forget the battery. How many amps is going to be going through that battery? 3 amps. Okay, that's how simple it is. Just remember this little trick right there. That is key and fundamental to understanding and being able to solve circuits like this. Okay, now let's take a look. Slightly more difficult, but not too bad. This is not a series. This is a parallel circuit. So in a parallel circuit, I'm going to screw that up. That might be right. It might be wrong. I don't know. In a parallel, the current, I'm just going to use the symbol for that, gets split up. Gets split up. So I'll put up. And how much it gets split up depends on the resistance. Okay, so basically what's happening is we got 6 amps coming down around the corner right here. It's going to go through the battery. So that means that it's going to be 6 amps coming through the battery, okay? But then when it gets to this point, excuse me, it splits up. Now, each resistor is 10 ohms of resistance. They're equal. So if they're equal resistance, that means that the current is going to split up equally, which means that you're going to get 3 amps going through this branch of the circuit, and you'll get 3 amps going through this branch of the circuit. I hope it makes sense, because guess what happens when they come back together right here? Those 3 amps from both branches add together, join forces, and becomes 6 amps altogether. Okay, so it does follow a logical train of thought here. It's logical. Take my word for it, but you can see it. So it is, current is a measurement of the flow of electrons. There are actually, we'll call them physical things, those electrons moving through the circuit, flowing just like water. It gets to split up, it gets to stay together, and in this case it split up, in the previous one it stayed together. All right, so you could probably figure out this one pretty quick. I'm going to not pause, but we got 1 amp coming out of the battery. Well, guess what? The current anywhere in a series circuit is the current everywhere. This is a series, 1, 2, 3, 4. They go in order, so there's no branching. So in other words, this that's supposed to be a 1. Let's just kind of cross that out. This will be 1 amp through that resistor. This will be 1 amp through that resistor. This will be 1 amp through this resistor. It's almost boring. And of course, this is going to be 1 amp coming out of the battery, because that's what it says right above it. So in a series circuit, I'm going to write that right here. Series. I'm not going to write so emphatically when I have to spell parallel with no help. But when a series circuit, the current anywhere is the current everywhere. So what is this thing? Well, if you look close, it's a parallel circuit, because what happens? The electricity comes this way. Some of it goes that way. Some of it goes this way. And then when it gets to this point, some of it goes this way and some of it goes this way. Okay, it is on this side. In fact, let me just go ahead and change the change the current here, I'm going to do a little highlighter. There probably is a button for this, but I don't recall what it is. There it is. Highlighter. So where'd my highlighter go? There it is. So on this side is going to be the high voltage according to, well, we're just going to ignore the battery. Like, trust, for this example, let's call this the high voltage side. The battery's backwards in this drawing, but we're going by where the current's coming from. Okay, so this is all high voltage. This is all high voltage. We haven't gone through any components up to this point, so all this is going to be high voltage. Okay, so what's going to happen now is, let's make sure I got the correct color here, is everything else, once it gets past that point, once it gets past the resistors over here, it's all low voltage. But the point I want to make here is that no matter what this looks like, we haven't gone through, if you're an electron coming out of the battery, you haven't gone through any components until, you know, you go through a component. And so you're at high voltage right here. You have a high electric potential all where it's highlighted. So what I'm saying is the 9 amps gets split up. And because they're all 3 ohms, it gets split up evenly. And so 9 amps split up 3 ways evenly becomes 3 amps here, 3 amps here, and 3 amps here. Okay, and then what happens is those 3 amps of flowing electrons come back here. The 3 amps comes down this way, it joins up with the 3 amps coming here, and it joins up with the 3 amps here, and it becomes that total of 9 amps again. And so when it goes through the battery, it'll be 9 amps. Okay, now you could definitely use Ohm's law here if you feel comfortable with it, but I'm giving you more of a visual or I don't know, diagrammatic look into how current gets split up in a circuit. Of course, we are going to be using Ohm's laws very soon here, V equals I times R and all the others. All right, one more I think here. So what's going to happen here? We have a compound circuit. It's a combination of series and parallel. And so what happens is the 1 amp comes around the corner here, and right here we have 1 amp going through this resistor. All right, it hasn't been split up yet. That 1 amp comes around the corner, 1 amp, I'll just notate it right there, and it hits these 2 resistors. Now, of course, you're probably thinking, what's going to happen when the resistors aren't exactly the same? That's a smart question. We're going to get to that another time, but for now, we're just kind of like visualizing this, how the current is flowing electrons, and because we have equal amounts of resistance, those flowing electrons are going to get split up evenly. So this is going to be 0.5 amps right here, and this one is, I could write, but this one is going to be 0.5 amps here. Okay, now those 2.5 amps, because equal resistance, that's why they got split up that way. The 0.5 amps is going to come together right here and become 1 amp again. And that's what's going to go through the battery. It's going to cycle through again. And I believe that's it. Yep. We're going to do finding voltage another time. So that's basically how you do it. Let me know if you have any questions.